Okay, we are continuing Part A review for the final exam. Using this figure down here, it says that EFD, which is this little piece right there, is 30. Find the measure of AFD. Well, the measure of AFD is a right angle because there's a right angle here. There's one over here. So that'd be 90. And then to find BFC, it's vertical to this angle, and that angle would be, since that's 30, this one would be 60, so this one's 60. Okay, number 10, you're using the diagram again. AFE, 9x minus 20, that's this angle, and BFA, oh, that's this angle. They're not equal. I'm just marking them so you can see where I'm looking. Find x by writing equations showing all work. What would these two add up to? Yep. So 9x minus 20 plus 3x plus 5, they add up to 180. You combine your like terms, 12x minus 15 equals 180. And I know you guys can solve this, so I'd kind of like to leave this and move on because you would add and divide. All right. Anyway, somebody want to tell me what they got already? It was a decimal, right? 16.25. All right, so number 11, it says that GFC is 29. Find GFD, which would be here. So since that's a right angle, you just do 90 minus 29. And that would be 61. Number 12, it says refer to the figure to answer the following questions. Identify the special name for each pair of angles. 1 and 3 are simply vertical. Vertical angles, excuse me. 5 and 16, they are outside of, they're opposite sides of the transversal, outside of the lines that are cut by the transversal Q. Oh, the transversal is Q, and 5 and 16 are alternate exterior. Angles 8 and 13 are on the same side of the transversal, which is line Q. And they would be called consecutive interior angles. Okay. More of 12. 3 and 9 are on alternate sides of the transversal P. So they're called alternate interior angles. And 2 and 3 are right next to each other, so they form a linear pair. The transversal is still P. I don't know. Really don't necessarily call it a transversal at that point, but anyway. Okay, number 13. Given that P is parallel to Q, line P parallel to line Q, that's here and here. What we need to pay attention to are what lines actually are involved if the measure of angle 3 is 62. So 62, I can fill in on the picture there. But what angles does that affect? It only affects the line, it has to be the transversal R, so it has to do with just those angles, not any of the ones down here. You need to be aware of that. So angle 5 would be 62 because those are alternate interiors. Angle 2 would be 118 because it's supplementary with the 62. 180 minus 62 is 118. The measure of angle 1 would be 62. It's vertical with 3. And angle 8 would be 118, alternate interior to angle 2. Lots of reasons why it's 118. Okay. I hope you tried some of these the other day when I asked you to. If not, I'm afraid I have to go pretty quick here. All right, 94 degrees on angle 9, and now what are we talking about? Well, that would be all the angles down here along transversal S, because we were already given P and Q parallel. So angle 13 is 94 as well. because it's corresponding with angle 9. How big would angle 15 be? Somebody already figured it out? Not 94. Yeah, 86. Ooh, my pen went crazy. 86 degrees, and then angle 12 would be 86. And the 16 would be 94. No two angles right next to each other would be the same. 15, it says P parallel Q by the consecutive interior angles theorem. Which angle pair must be supplementary? Well, if P and Q are parallel, what are the angles that are between the lines on the same side of the transversal? So that's going to be stuff like angles 2 and 5. Let's just go down the line. 3 and 8. 10 and 13. And then also 11 and 14. Thank you. Okay, 16 says refer to the figure. I believe you don't have this, right? Do you not have the multiple choice stuff? Okay. No, don't. I don't like those answers anyway, because they're not right. And I'll explain why. If you're given the measure of angle 1 congruent equals the measure of angle 5, what postulator theorem justifies that S is parallel then to T? Well, if those angles are congruent, then we have parallel lines. Okay, so what kind are they? Yep, so if corresponding angles congruent, then we got parallel lines. That is the converse of the corresponding angles theorem or postulate. So then I didn't like the answers because they didn't say the converse. So if you wrote corresponding angles theorem converse, then that's the same thing. Okay, 17 also, this is not on your thing. The actual reason the measure of angle 3 is congruent equal to the measure of angle 6, then the theorem that justifies S being parallel to T would be if alternate interior angles are congruent. It's the converse of the alternate interior angle theorem. Okay, then you've got parallel lines. Remember we used the arrow for implies or then, or you can write the word then. It is the converse of the alternate interior angles theorem. 18, I need to get rid of that junk too, since it's wrong. Given angle 2, measure of angle 2 congruent equal to the measure of angle 7, what kind of angles are those? Alternate on the exterior. So if alternate exterior angles congruent, then you have parallel lines, which is the converse of the alternate exterior angles theorem. Okay, 19. Oh, another one. Get rid of these little guys. No, I want the whole thing gone. Go. Oh, there we go. Given the measure of angle 4 and 6, that these are supplementary, then that would be if consecutive interior angles supplementary, then you have parallel lines. Okay, number 20. Find the value of x so that A would be parallel to B. If A would be parallel to B, then these angles would need to be congruent corresponding angles. So 6x minus 10 would have to equal 3x plus 38. Subtract 3x from both sides, you would get 3x minus 10 is 38. Add 10 to both sides, you get 48. And then divide by 3, and we would have an x of 16. I did not show the steps in between because I'm kind of in a hurry to get you the answers and the setups. 21, explain. Oh, what kind are these? Because we have, all right, vertical angles are congruent, then we know that 5x minus 7 is equal to 3x plus 17. just so you know what the solution is, it would be 12. Yes? Okay. Subtract 3x, 2x, add 7, divide by 2. Number 22, in the figure at the right, the measure of angle IJK, that's the whole thing, is 121. If IJE is 37, EJK, 3x plus 12. Well, let's find out another measurement for EJK. Since we know the whole thing's 121, we could subtract 37. What's that going to give me? Either that or we got to add those two. 3x plus 12 plus 37 equals 121. So you got choices on how you approach the problem. Either way, we should get the same end result. What is 121 minus 49? So I got 3x equals 72, and they should be getting x is 24. The other way you could have done the problem is first figure out that angle EJK is, what was 121 minus 37? Did anybody do it like that? 84. And then you could have said 3x plus 12 equals 84. And you would have subtracted 12 and gotten 72, and you still would have got the same answer, right? Okay. 23, you've got three angles that add up to 180. All right, so subtract 90 and subtract 46 and get it done. Angle 1 is 44 degrees. Classify the triangle twice, once by its sides, once by the angles. By the sides, it can be scalene, isosceles, or equilateral. This has three sides different, so it's scalene. This one has two sides equal, so it's isosceles, isosceles. Now, by the angles, the first triangle's angle up here is the one you look at. These are both little, but this one's big. It's over 90, so it'd be obtuse. And this triangle over here has two little bitty angles, but it also has one ginormous angle that's over 90, so it's obtuse. Okay, that's what classify means, give names for angles or sides. 24, this thing is isosceles, isosceles. And what else? Well, all the angles are small, so it's acute. And then by sides, this one, three different sides, scalene, and then a right angle makes it a right triangle. Okay, classify this triangle. It's, what's the two names? All right, so if by sides equilateral, by angles equiangular. And 25 says RST is isosceles and a base angle is 27. Find the vertex angle. The vertex angle is the one that's not the equal angles. So where do I have a vertex angle? Where is it? At the top? This one? That's what I want to know. If one base angle is 27, the other base angle is also 27 because base angles of an isosceles triangle are congruent. So now to find the vertex angle, I take 180 and subtract 27 twice. Or I take 180 and subtract 54, which is the sum of 27 and 27. So what's that? 126. Okay. Number 26, use the figure at the right. What you would like to remember about this is the remote interior angles added give you the exterior angle. So 7x minus 2 plus 5x, bless you, plus 8 equals 150. Now, I know someone's already thought of another way that they started to look at that problem. Okay, so I'm going to address that right now. Did anybody think of starting off the problem differently? No one looked at finding this angle right here real quick? I bet somebody did. Okay, so how big would it be? Pretty easy to do mentally, right? 180 minus 150. So you might have said all these add up to 180. That's another way to do the problem, okay? So you'd be 12x, negative 2 and 8, 6 plus 6 equals 30, forgot, equals 180. You could have done the problem just like this and get the same answer. So I'm going to get 12, and this problem would give you 12 also. Okay, so I don't care which way you do it. Uh-oh, Kylie, tell me what's up. You look like you had a question. Okay, so like on solving them, you mean? All I did was say that either you do this and you add these up to equal 180, which is be there, which all I did was to add 5x and 7x, 12x, 8 minus 2, 6, and then add 30 to get 180. All right, and then I just simplified. Okay, so this way is saying this angle plus this angle equals the exterior angle. Either way works to solve the problem. I hope that was good enough. Sorry, I went kind of fast. All right, so we've got an isosceles triangle here. As soon as you see an isosceles triangle, then base angles are congruent. So that means angle 2 is also 35. But then they said the measure of angle 2 is 3x minus 4, so we need to take the 3x minus 4 and set it equal to 35. Okay. Then we can just solve by adding 4. That gives us 39, and then divide by 3, we should get x is 13. I hear page turning to get to number 28. Okay, here's the biggest mistake I always see about this question. Kids want to take and add these up and say it equals 180. They're not angles. What are they? Yeah. It says this is an equilateral triangle. So all of these sides are equal and all of the angles are 60. But I'm not talking about angles. So it says find x and the length of a side. Find x and the length of a side. So what could you do to find the length of a side? Okay, what pair of sides did you pick? It doesn't matter. I'll just do what I want. You do what you want. And then we'll see if we get the same answer. So I'm going to do these two. And I'm going to get 7. Did you pick a different pair and get 7 still? So doesn't matter. It's 7. And if you plug back in 4 times 7 minus 1, you should get 27 for each side. Okay. Whoop. 29, find the measure of the indicated angles. First angle, let's get angle 1. What is it? Quickly. Okay. Go over to the triangle where angle 2 is and find the angle 2. That's because the 3 angles add to 180. 70 plus 60 is 130. 180 minus 130 is 50. Then go over here and do angle 3 quick. 60 plus 40 is 100. So how big is angle 3? And angle 3 and 4 are a linear pair. So how big is angle 4? It's also equal to 60 plus 40. Because those are the remote interior angles to that exterior angle. Okay, 30. Find the numbers. Let's go for 1. You've got a 90 and a 40, so the other one is 180 minus 90 minus 40, which is 50. Then go find angle 2. If you have a right angle here, you have a right angle here. So 180 minus 90 minus 70 gives us 20. Then we say, well, angle 4 plus angle 2 plus angle 3 is a straight angle 180 degrees. So I say, oh, 40 plus 20 is 60. 180 minus 60 gives me angle 3, 120. Okay. Number 31. You got the point -2, 1, and it's left to up 1 to plot that. Where is it? If it's rotated 90 degrees about the origin, where is K prime? Well, if I go 90 degrees about the origin, I am going to go 90 degrees that way. It's going to go to -1, -2. And let me explain that in your little note sheet, which you get to have a formula sheet for your final, the rule says take x, y, the point, and transform it by multiplying the y by -1 and replacing it with, changing it with the x. So it's y equal, xy becomes -y comma x. So what I did, change the sign of the y value was -1, and then I switched it. So it would be -1, -2. Follows the rule and follows the visual. 32, we're going to go 180, take 1, -4, which would be here. Rotate it 180 degrees about the origin. Let me show you what that looks like. You take that point and you go through there, 180 degrees, the same distance, so it's going to be at -1, 4. Your rule that will be on your formula sheet says take the point x, y, and change the sign of both the x and the y. I was at 1, -4. I went to -1, +4, and that's where I landed. Bingo. That's where A prime would be. Okay, number 33 says to take a 270. We're starting at -2, -2, and we're going to go this way. 270's rule in your paper says take the x value and change the sign and switch it with the y. It goes like that. So if you take the x value and change the sign, it would be +2, and you switch it with the y, we'd be at -2, 2. -2, 2 right there. Oh, that's exactly where I was headed. Okay, 34, point T, -2, 1 is reflected in the x-axis. You should know the x-axis is the horizontal axis right here. Now, it says to explain how you did it. There's two different explanations you could use. You could say I counted how far away the point was from the x-axis and went over to the other side the same distance. Or you could say I changed the sign of y. All right, so it'd be -2, -1, the new location. 34 is asking us to take 1, -4, the point R, reflected over the y-axis. The y-axis, of course, you know, is the vertical axis. One way you can describe it is to say that you counted how far R was to the right of the line, and then you went the same distance to the left. So otherwise, you can say change the sign of x, which would be -1, -4. 36, we had some trouble with this on the last unit test in Chapter 9. We're going to reflect in the line y equals m. I'm hoping I'm going to catch a few more of you on this one this time. If I am reflecting point S over line M, I am going to go straight towards the line and then go to the other side the same distance. So where am I going to land? Yeah, W. Now it says name the reflection of point T in line SV. SV is not that same line. SV goes this way. You might have to go across TW for all I know. All right, now it says the reflection of point T, which is here, If you're going to go straight towards this line and then go to the other side, you're going to be at W. Okay. Now I'm going to take segment TU, which is right here, and I'm going to reflect over line M to the other side, so it's going to be BU. Yep. Can't be UV. Has to be BU. Name the reflection of XW, so I'm going to find XW's right here, over line SV, the blue line. W is going to come flopping over to the other side and go up to T. So that's going to be TX. X doesn't move because it's on the line. (40). What's the image of -2, 1 under a translation of 5, 3? What that means to do is go +5 + 3. Well, what does that mean? Add 5 and add 3. So -2 + 5 is 3. 1 + 3 is 4. There's your new point. What's the image of P at 1, -8 under a translation of -2, 4? Well, you're going to subtract 2 and add 4. 1 minus 2 would be -1, and -8 + 4 is -4. There's your new location. Okay, so just put the vector underneath the point and combine. 42. If you 4 foot wide, 4 inch wide by 6 inch long picture is enlarged to 10 inches wide, what's the scale factor? All I care about is the wide numbers. And since it's been enlarged, the larger goes on top, so that'd be 10/4. You can reduce that to 5/2, or you can write a decimal by dividing and get 2.5. The number of pixels on my screen is increase. It says increase, so put the larger number on top of the smaller number to get the scale factor. You can cancel out those zeros and then reduce 15/12 by dividing by 3, 5/4. Or you could type in the calculator and get 1.25. But do not round that to 1.3. You need to leave it at 1.25. Okay? Do not round to 1.3. What kind of transformation is this? And we missed this on that last test. Dilation. We have had transformations that it consisted of reflection, rotation, translation, and dilation. And this would have been a reduction by 1/3. What vector describes this? We missed this a lot on that last test too. All you got to do is go from point A to point A prime, count, and write a vector. It's just the direction that you went. You went 1, 2, 3, 4, 5, 6, 7 to the right. That's +7, and then down, -3, down 3. Good luck. Yes. No. No, because that would be telling me to go left 3 and up 7. Okay, so it does matter what number you have where. All right? Glad you asked. Now, a translation was a slide of a figure. It was just our slang for it. A reflection was a what? Remember the flip? And a rotation was, what do you do with the steering wheel? Turn. (49), all you got to do is look at the triangle congruence statement to get the answers. What corresponds to segment DL? Well, D is the first letter, L is the last, so it would be ES. Naming that angle, JLD, go look at the letters. J to L to D, so I'm going to do G to S to E. Angle GSE. (50), you got a quadrilateral MNOPQ, whatever, MNQP. is made of two congruent triangles. NP, that segment in the middle, bisects angle MNQ, which is up here at the top, so these are going to be equal. And it bisects MPQ, which is the angle at the bottom, so these are going to be equal. Bless you. It says if MNQ is 40, that's the whole thing up here. How big would each of these been then? Yeah, half of 40, 20 each. And then it says if MPQ was 120, even though it doesn't look like it, if it had been 120, then each of these would be 60, half of 120. So then we want to know what angle M is. I'm going to find this angle by using the one triangle here. Do 180 minus 20 minus 60, and that is 100 degrees. Okay, 51. Given a drawing with congruent parts marked, state which triangle congruence theorem would prove the triangle's congruent. It's okay to assume that common parts and vertical angles are congruent. All right, so let's mark the vertical angles first. And now I look at it and I say I see an angle, a side, and an angle. ASA. What do you think on number B, on letter B? Side and an angle and a side. All right, and C, that's hypotenuse leg because you have right triangles and the diagonal is a hypotenuse and the other side's a leg. So this is not ASS. Don't write that on your paper, please. It's hypotenuse leg. It's not SSA. No donkey. 52, this would be shared side, 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 side. And this one is angle, angle, side. The side's not between the angles. Okay, we're on the page with a proof. We are given that we got some parallel lines. All right, it's given. That means we got some angles congruent. Angle ADN is congruent to angle YND because if you have parallel lines, then alternate interior angles are congruent. All right, why would DA be congruent to YN? It's given. And it's already marked on the picture. Now DN's congruent to itself, reflexive. Yep. And now the triangles are congruent by a side, an angle, and a side. And now all other parts are congruent by corresponding parts of congruent triangles are congruent. CPCTC. Okay, try another proof. Obviously, you're going to have a triangle proof on the final. Which triangles are congruent? Oh, in the figure and by what theorem? Well, you can mark this shared side, and then you got parallel lines, so alternate interior angles would be congruent. Okay, so I could say triangle MNH is congruent to triangle GHN. And that would be by angle, oh, wait a minute, an angle and an angle and a side. Now the next one, you've got some parallel lines, and then you got to think of this as the transversal. So that means this angle would be congruent to this angle because they're corresponding. So now I can say triangle ABE is congruent to triangle ABE would be FCD. And that would be by a side, angle, and a side. Okay. Given angle P and T are right angles, I'm going to make them right, put it on the picture. And R is the midpoint of PT, which means POT is cut in half. And QR is congruent to RS. These triangles, PQR or QPR, I don't know how you wanted to write it, but let's do Somebody want to tell me how to start it? QPR? Okay. QPR. Ooh, I need R. Is congruent to triangle. If I say Q to P to R, I got to do S to T to R. And that would be by HL. And the long sides are the hypotenuse, the short legs congruent, and you have a right triangle. It has to be a right triangle. State the angles in each triangle from smallest to largest. Remember, angle measures are the smallest angle measure is opposite the smallest side. So that'd be angle F. Then it would be angle E. And the biggest angle is across from the biggest side, so that's going to be angle D. Right now, the shortest side, that's got you. We better be able to do that since they're labeled. ED is the littlest. DF is the medium, and EF is the biggest. In this one, it's obvious what the angles are, because angle A's got the smallest number on it. Then would come angle B, and then angle C. Wasn't supposed to be necessarily in alphabetical order. The side opposite the smallest angle is BC, so it's the smallest side. Remember how to do it if you don't even have the letters. The side opposite angle B would be AC. Oops. And then the side opposite angle C would be AB. .55, we'd need to find the missing angle. Can you guys tell me what this measurement is, please? 120. How big? Oh, okay, so that means the smallest angle is angle M, then angle L, and then N. So sides, it's the opposite letters from what you see. Across from M would be LN. Across from L would be MN. Across from N would be ML. Okay, smallest angle for part D would be across from 11, which would be angle P. Then comes angle Q, and then R. R is the biggest because it's across from the biggest side. Then QR is the littlest side. PR is the medium, and QP or PQ is the biggest. Okay, 55 is asking us to name some of those segments. If you're seeing an angle bisector, you should be looking for a ray that cuts an angle in half. Find it. Ray. You got to go from the vertex to through L, so it's got to be GL. The median goes from a vertex to a midpoint of a side. The side that's cut in half is down here, so it's got to have M in it. What's it coming from? MH or HM. Segment HM. An altitude is a tallness, should be a segment. It's got a right angle and it doesn't cut the side in half. IK doesn't have to cut the side in half. And then the perpendicular bisector, you go for the other right angle, but it cuts the side in half and it's also a line. So that's going to be that big thing right there. We had to use two letters. We had the same picture the other day, JM. Okay, we'll do a few more of those. Being told that AF is congruent to FC. That's like this segment here and this segment here are equal. BH is congruent to HC, so we got another bisector up there. And ABE, that would be an angle up here, is congruent to an angle EBC, which is over here. Okay, so I got an angle cut in half right there. There's your angle bisector, BE, ray BE. A median goes to a midpoint, which is here. That's going to be BF, segment BF. Okay, now an altitude's a tallness. That's going to be BD or DB. And a perpendicular bisector cuts the side in half. That's going to have to be that line, GF. given YW is an altitude, which of the following is a true statement? If the YW is an altitude, you've got a right angle here and here. So YWZ is a right angle. A is true. That's all you know for sure. In 63, if FG is a median, it cut the side in half. Okay, so what would be true would be that GD equals EG, and that is C. (65) If FG is a perpendicular bisector, complete the 5 true statements. If that's a perpendicular and it cuts it in half, right, then angle DGF is a right angle. And there's another one of those down here, EGF would also be a right angle. Both of those. DG would equal EG. G is the midpoint of ED. And one thing weird is that DF would actually be congruent to EF. It'd have to be an isosceles triangle, actually. Okay, I will continue these, and oh wait, that's not even the right one. So I'll continue after that and finish those up for you shortly, and you can find it online. I'll send out a key as well.